So welcome back to 4.6, part 2, example 2. Using a calculator, find the error in using the linear approximation to f of x equal e to the x at x equals 0 to approximate the fourth root of e. So one of the things we do have to be careful, remember, it is an approximation, so we might get a slight margin of error. So here we're going to pretty much calculate that. So we're going to say that f prime of x equals e to the x, obviously, right? And then we can say that f prime at 0 also equals e to the 0, which is equal to positive 1. And then we know that f of 0 equals e to the 0, which is also equal to positive 1. So now our line, right, in point slope form would be y minus 1 equals 1 times x minus 0, which in this case is just y minus 1 equals x. Add 1 to both sides, so you get that not L, y equals 1 plus x, and that's pretty much going to be our L of x. And then from there, we can figure out what the approximation is. So we're going to say that L of 1/4 equals 1 plus 1/4, which is obviously 1.25. Right now, so now to figure out what the error is, we're going to take the actual value, the absolute value of the actual value, and then we're going to subtract the estimated value that we obtained. All right, take the absolute value of that, and that's pretty much going to give us our error. So we can say that the error is approximately equal to. So now all we have to do is pretty much just check this out in Desmos. Easy as that. So if we have the fourth root of e, or e raised to the 1/4, we get 1.284. So we're going to say that the actual value is 1.284 minus 1.25. So we're going to say that the error in this case is 0.034. So again, the margin of error is the actual value minus the estimated value, the absolute value of that. Okay, so for the tangent line to example 3, so for the tangent line to f of x equals x squared minus 3x plus 5 at x equals 4 to have an error of at most 0.1 when approximating f of 4 plus h, find the range of the values for h. All right, so one of the things we want to do here is, again, first, let's figure out what f prime is, right? So we have f prime of x equals 2x minus 3. All right, and we know that f prime at 4, again, start playing in the a value, which in this case is equal to a equals 4. So this is going to be 2 times 4 minus 3, which would be just 8 minus 3, which is positive 5. And then we know that f of 4, right? So now let's plug it into the original equation. So that's going to be 4 squared minus 3 times 4 plus 5. So that's going to give us a total of positive 9. All right, and then we're going to write our line. So again, point slope form. So it's going to be y minus y naught, which would be y minus 9 equals the slope, which is 5, times x minus x naught, which in this case happens to be positive 4. So we just solve for y here. We're going to get add 9 to both sides. So you end up with y equals 9 plus 5 times x minus 4. And then from there, we're going to figure out what's f of 4 plus h. That's one of the things we're missing. So f of 4 plus h is equal to pretty much 4 plus h quantity squared minus 3 times 4 plus h plus 5. And then we simplify that. We're going to end up with 16 plus 8h plus h squared minus 12 minus 3h plus 5. And then from there, ladies and gentlemen, we just simplify one more time. So that's going to be h squared plus 5h plus 9. Okay? And then to figure out the linear approximation, right? So we have that. We're going to say that f of 4 plus h is approximately equal to L of 4 plus h, right? Because that's pretty much what we're trying to figure out. We're trying to minimize the error here. So one of the things we can do here is, again, plug it in. So that's going to be equal to 9 plus 5 times 4 plus h minus 4. These two go away. And then we're left with 9 plus 5h. All right. So now we can say that the error, to figure out the error, remember, it's the actual value minus the estimated value. So the error is going to be f of 4 plus h minus L of 4 plus H. All right, so that's pretty much what we're trying to minimize, right? We're trying to make this small enough so it's at the most 0.1. At the most 0.1. Okay, so that has to be less than or equal to 0.1. Okay, so from here, again, we already know that f of 4 plus h is equal to this, right? H squared plus 5h plus 9. So we're going to substitute that back in there. That's going to be h squared plus 5h plus 9. And then L of 4 plus h is going to be minus 9 plus 5h, right? Substitution. And then less than or equal to 0.1. And then again, simplify. So again, this becomes negative. This also becomes negative. So that's nice enough. These two disappear with the original one. And we're just left with the absolute value of h squared has to be less than or equal to 0.1. And now technically, right, h is going to be positive, right? So here we have to have a positive or a negative. So therefore, we're going to say that if we take the plus or minus the square root, so h squared equals 0.1. We take the square root of that, we end up with h squared being between 0 and negative 1, or positive 1, positive 0.1. And then therefore, our h is going to be between negative 0.316, less than or equal to h, less than or equal to 0.316. So in order for this to happen, pretty much h has to be between those two values in order for this to have a margin of error of at the most 0.1. So that's exactly what it means, right? So at the most is going to be h has to be between negative 0.316 and positive 0.316 to have a margin of error of 0.1.